Alright, part 2. It starts with that quick check. That again is part of your practice problems. If you need some help, you can do it now. Pause the video. If you need some help with it, let me know. Otherwise, I'll check it later. So we come to example 4 now. We got the picture of a parallelogram with an extended side there. They want us to find the measures of angles x, y, and z. So I'm going to start off with x here. If I look at x and I know this measure 80 right here, these two angles are what? Opposite angles. And they are congruent. So I know that x equals this other angle right here, which is 80. So there's x. Next I'm going to go to z. And so I know this is 80, and how does it compare with z? Well, those are consecutive angles, the 80 angle and the z angle. And consecutive angles are supplementary. They add up to 180 degrees. So I know z plus 80 equals these two angles, consecutive angles, add up to 180. So if I subtract 80, and do a little messy work here, minus 80 and minus 80 from this side, I get z equals 100 degrees. So now we know this is 80, this is 100. We need y right here. So let's see, I know y and this angle right next to it would add up to 180. They're what? Linear pair from geometry A. So if I knew this angle, I could figure out y. Well, that's easy. I go to the angle opposite, they're equal. So it's the same as z over there. This one's 100. So 100 plus what equals 180. This one would be 80 also. So there we have it. We have x is 80, y is 80, and z is 100. Let me know if you have any questions. Example B here. Now pay attention to this one with the diagonals. We'll start off with an easy one. Here's opposite angles. They're congruent. So z is 120. Now, when you have this diagonal right here, these are parallel lines, right? Opposite sides, cut by a transversal. We go back to that lesson. These are opposite interior angles, and they're congruent. So whenever you have, the diagonal in, cutting that angle into two pieces, if you go on the opposite side, they're always going to be congruent because of alternate interior angles. So this one's 35. So now how do we get x? Well, we know this whole angle plus a consecutive angle right here will add up to 180. So we take this whole thing, which is x plus 35, plus its consecutive angle right here, which is 120, has to equal 180 degrees. Sorry for my writing, I'm a little rushed. So we add up these two numbers right here. We get x plus 155 equals 180. Subtract the 155 from both sides, and we get x equals 25 degrees. There we have it. If you have any questions, let me know. Example C, a little bit tougher even. So I am going to start, let's see, with that thing we were talking about here. Here's the diagonal on opposite sides of the diagonal right here. They're going to be congruent because parallel lines cut by a transversal. So this x is 30 degrees. Right here we have a linear pair right here. These two have to add up to 180. So 70 plus 110. So z is 110. Okay. Now we got this one left. Well, I know one of the angles in the triangle. If I knew this one, I could figure out that one. Well, these are vertical angles right here, z and this one right here. So this one's also 110. So now we have 140 degrees plus 40 more would make 180 for these three angles in this triangle. So that's how that's solved. a little bit about the parallelogram and some of the old stuff like vertical angles, and the angles of a triangle always add up to 180, linear pair. You'll be using those properties. Quick check I'm going to let you go ahead and do as part of your practice problems. I'll check it later, but if you need any help, let me know. Same with B. Let's go to, I'm going to skip example 5. It's not going to be in your practice, so don't worry about it. You would end up using the distance formula and finding out that in a rectangle that the diagonals are the same measure. Not in a parallelogram per se, but a special parallelogram, a rectangle. These diagonals are exactly the same length. So we're going to look at properties of a rectangle right now. It is a parallelogram, so just like a parallelogram, opposite sides are parallel. Let me pause this. Guess I might have to write it in crummy writing. Alright, here we go. So opposite sides are parallel. Opposite sides are, just like a parallelogram, congruent, equal. You can put in equal or congruent. Just like a parallelogram, opposite angles here will be equal or congruent. Consecutive angles will be supplementary, add up to 180, just like a parallelogram. So those are all the same. Sorry about that, and here you do it better. Diagonals still bisect each other, cut each other in half. So those are all from being a parallelogram. This is different. Here we have 4 right angles. All the angles in the corner are right angles. Now these diagonals don't cut them in half. We'll see what happens with those, but they are 90 degrees there, right angles. And unlike a parallelogram, the diagonals not only bisect each other, but they're the same size. They are congruent. Oops, that's a bad equal sign, bad congruent sign. I'll let you spell it in or put a good one in. So the diagonals are the same size. Let's look at some problems. Example 5 here. We got quadrilateral MNOP is a rectangle. MO equals 2x. So this diagonal is 2x minus 8. That whole diagonal. And NP, the other diagonal, is 23. Well, we know the diagonals in a rectangle are congruent, so our equation is 2x minus 8 equals the other diagonal, which is 23. So we add 8 to both sides. And we get 2x equals 31. Divide by 2. And x equals 15.5. Okay. Next you have a quick check. I want you to do that on your own. Let me know if you need any help though. Example 6. We have side A, or diagonal AC. This whole diagonal right here is 4x minus 13. DP, which is just this little piece, it's not the whole diagonal, but this little piece is x plus 7. So this whole diagonal does not equal this little piece, it actually equals 2 of them, because these pieces are the same, and since the diagonals are the same, these little pieces over here are the same. So we can say it takes 2 of these little ones, 2 of the DPs, to equal the whole AC. So there's 2 ways you could do it. I'm going to do it the slow way here. X plus 7 twice. Two of those equal the whole AC, that whole diagonal, which is 4x minus 13. Alright, so we combine our x's over here. We have 2 x's. 1x plus 1x, 2x, and the 7 plus 7 is 14. Equals 4x minus 13. So I have x's on both sides. I usually like getting rid of the smaller ones here. And I'm going to subtract 2 x's and get my x's on this right side here. So on this side we have 14 equals 4 minus 2 leaves us 2 x's minus 13. So over here we'll continue solving. We'll get rid of the minus 13 with plus 13. So we get 2x equals 27. Divide by 2. (27) divided by 2 is 13.5 equals x. Alright, let's see what's next. A quick check, that one you'll do on your own. And last example 7. What do we have here? Angles now. The measure of angle RSU. So we go from R to S to U is just this little piece right here. Is 3x minus 5. And U, angle UST, go from U to S to T is this angle right here. This second one, okay? So these two pieces of what they're giving us is 4x plus 4. Well, we know if we take this whole angle in a rectangle is 90 degrees. So we're going to add up these two pieces will equal 90 degrees, that whole angle in the corner. So we have 3x minus 5 plus the other piece, which is 4x plus 4, equals the 90 degrees. So 3x plus 4x makes 7x. The minus 5 and the plus 4 make minus 1. And we'll get rid of subtraction with addition. So 7x equals 91. And we divide by 7. And we get x equals 13. There you have it. I don't think there's any more. If there's a quick check, you'll do that one on your own as part of your practice, and then do the practice problems. Let me know if you need any help. Good luck.